Hello friends, today we are going to learn about differential equations of first order. An equation which contains differential coefficient is called a differential equation. The two examples are given below. dy by dx plus y is equal to 0. This equation contains a differential coefficient dy by dx, and second one is dou y by dou x plus dou y by dou z is equal to 0, where here y is a function of x and z. The differential coefficients are dou y by dou x and dou y by dou z. Okay, there are two types of differential equations. First one is ordinary differential equation. Ordinary differential equation contains derivatives with respect to single independent variable. In the examples given below, first one is an ordinary differential equation because it contains only derivative with respect to x, where x is an independent variable. There are no other derivatives with respect to other independent variables. Okay, so this is an ordinary differential equation. Now the second one is partial differential equation. Partial differential equation contains derivatives with respect to more than one independent variable. Here the second example is the partial differential equation. It contains derivatives with respect to x and z. Both x and z are independent variables, and y here is a function of x and z. Next we will learn order and degree of a differential equation. Order of a differential equation. Order of a differential equation is the order of highest differential coefficient in the differential equation. Consider this example: d square y by dx square plus L dy by dx plus cy is equal to 0. Now what is the highest differential coefficient? D square y by dx square. So what is the order? Order is 2. Order is equal to 2. Now consider the next example. This is the first one and this is the second one. D n y by dx raised to n plus a y raised to n is equal to 0. Here the highest differential coefficient is dny by dx raised to n. So its order, this differential equation's order is n. It's an nth order differential equation. Here the y raised to n, that is simply the n here is simply the power of y. Okay. Now next is degree of a differential equation. Degree of the differential equation is degree of the highest derivative after removing the radical sign and fraction. So to find the degree of a differential equation, first you must check whether the differential equation is a polynomial or not. If it is a polynomial, then degree is defined. Now consider this example: d cube y by dx raised to d cube y by dx cube plus 4y square is equal to 0. Here the highest derivative is d cube y by dx cube, right? So what is its power? Its power is 1. So here the degree is 1. Actually, degree of the highest derivative after removing the radical sign and fraction is the degree of differential equation. Degree means here it is just power of the highest derivative. Now consider the next example: d square y by dx square is equal to 1 plus square root of dy by dx. Now at the first glance, when you see, this is not a polynomial. So first we have to convert this differential equation into a polynomial. So take this 1 to the LHS and square the LHS and RHS. So d square y by dx square minus 1 is equal to square root of dy by dx. Now squaring both sides, d square y by dx square minus 1 the whole square is equal to dy by dx. Now the radical sign is gone. So now this will become a polynomial. Okay, so d square y by dx square the whole raised to 2 minus 2 times d square y by dx square plus 1 is equal to dy by dx, using the expansion of a plus b the whole square. So what is the highest derivative here? D square y by dx square. What is its power? Its power is 2. So degree of this differential equation, that is d square y by dx square is equal to 1 plus square root of dy by dx is equal to 2. Now consider the third example. D raised to 4 y by dx raised to 4 plus sine of d cube y by dx cube is equal to 0. Here the degree is not defined because it is not a polynomial. We cannot convert this differential equation into a polynomial. The derivative is coming inside the trigonometric term sine.